Well, thanks very much, Dave, for the introduction, and to NYU Abu Dhabi Institute for the invitation to come. It's my first visit to Abu Dhabi, and I've been at NYU a long time, so this is a long overdue visit. I'd also like to acknowledge Neda Ahmed for organising my visit. It's been very superb organisation. So what I want to do today is talk to you about the fossil record for human evolution. That's what I study. I'm a researcher who studies the fossil record, the paleontological perspective. And this is going to be a personal account. One of the things about the fossil record for human evolution is it's a fast-moving, dynamic field. So many new discoveries are being made every year. It would be hard for me to present human evolution in a nutshell in a 45-minute presentation. So what I thought I would do is give you a few snapshots, if you like, through the lens of my own research, so you've got a feel of what kinds of things I do, and it should give you a little bit of an introduction to some aspects of human evolution too. It's not advancing. There's a prompt here, Dave. Is there a tech person? It's frozen a bit. It needs a code or something, I think, entered. Great, thanks. Is that good now? Yes, thank you. So I'm going to start with David's own field, because one of the areas that's been so important in understanding human origins is the genomic field. And this is genetic data highlighting the relationships of modern humans, shown by Darwin here, to our closest living relatives. And also it's given us a time frame. So this is based on genomic data. Morphological data, the sort of anatomical data, supports this evidence too, but it gives us a time frame using a molecular clock model. And humans and chimpanzees are one another's closest relative, and that was about 6 to 8 million years ago when we diverged as a lineage from chimpanzees. Chimpanzees have gone on their own evolutionary route, we've gone on ours in the last 6 to 8 million years ago. And that time period becomes important when I talk about the fossil record. More distantly related to us are gorillas, orangutans, and the gibbons and siamangs, and you can see that those have diverged much more distant in the past. One of the things that I want to highlight here, though, is that humans, when they diverged here, have a very extensive fossil record. One of the things that we can say about the human record is that people have been working diligently across the globe trying to find fossils related to human origins, and we now have probably one of the most complete and one of the best documented records of a single extinct species or single species of any species on the planet today. One of the things I wanted to highlight for you is just a little bit of terminology for you so that you're clear about some of the terms I'll be using. The groups that you see here are all called hominoids. These are the apes and humans. The great apes, the orangutan, gorilla, and chimpanzee, and humans are what are called hominids. And then the group to which we belong are called hominins. And this has been changing a little bit in the last decade or so. But hominins are what I'm going to refer to. Now, what that means is it's all of the humans that have lived and our extinct relatives since we diverged from the chimpanzees at 6 to 8 million years ago. Everything on our lineage is going to be referred to as a hominin in this presentation. Let me explain, or let me go back a second. So one of the things that's going to be important here is that since humans originated, there's been an important series of changes that have taken place since we departed from that last common ancestor. There are a number of morphological changes. Now, one of the things is that this is genomic data that I've presented at the beginning, but the paleontological record is critical here in understanding human origins. Because if we just had the genomic data, we would know that humans and chimpanzees were one another's closest relatives, and we would know probably a good approximation of when those lineages diverged. But what the paleontological record tells us is 2 or 3 important things, and that is that it tells us what evolutionary transformations have taken place, step by step, the order in which evolutionary change took place. And secondly, it tells us about extinct relatives that we would never have any understanding of in the distant past. And you'll see we have a lot of extinct relatives that we know from the fossil record. Here are some of the specializations of humans that separate humans, here shown as a skeleton here, with a chimpanzee skeleton. And you can see there are quite dramatic differences between us. Humans are special kinds of hominoids, apes and humans. They have diverged and have created a whole series of specializations. I'm only going to focus on the skeletal specializations here, and these are just a few of them. And the reason I'm focusing on that is those are the parts that get preserved in the fossil record. I mean, there are many things that are unique to humans that don't get preserved. For example, we have a very unusual hair distribution, very little hair covering on our body, except for strange tufts on different parts of our body. We also have salty water that trickles out of our eyes when we are happy and sad. A very unusual feature, unique to humans. There are many things. Language is another area that's unique to humans. Of course, we don't have those preserved in the fossil record, and so my list is a short list by comparison. But here I'm just going to quickly run through these. Brain expansion, large brains in humans. The face has become relatively short. Canines have become very small. They are much larger in chimpanzees. The lower premolar, the tooth that the canine shears against in the lower jaw, has become specialized and no longer has a sharpening function to it that you would see in chimpanzees. Ours has become more like a molar tooth, one of the cheek teeth. There's been changes in limb proportions, as you can see, short arms and long legs, and modifications of the pelvis go along with that too, whereas chimpanzees have long arms and short legs. Humans have short hands with a well-developed thumb, a unique feature of humans compared to chimpanzees that have long hands and short thumbs. A more upright posture is an obvious one. And then features associated with bipedalism. This is walking on two legs in an upright posture. You and I have a very distinctive style of walking that's not very common among mammals. Most mammals that are what we would call bipedal, moving on two legs, do it in kangaroo style, hopping. That's the common pattern. When you've got two legs, you tend to hop, whereas you and I have a striding bipedal gait. In other words, we walk one foot in front of the other like that. And I'll come back to that point. It's obviously something critical, and we know from the fossil record that the two earliest changes we see in this lineage from that common ancestor when we diverged from chimpanzees is canine reduction was a very early change, as was the move to bipedalism. Those were two important changes that took place very early on in our evolutionary history. Now, hominins today, we're it. We are one species, and we are the only hominin species alive today. That hasn't been true in the past. My research and my colleagues has shown that there's an incredible diversity of creatures that were like us and that are closely related to us from the fossil record. And here's a chart showing that. This is the time range here, going down from present day to 8 million years ago. And there are now more than 20 species of early hominins described. So this is work that's been going on for the last 150 years, a large number of different species. We can sort of just summarize this very quickly, and because there are a couple of interesting points that we can see from this, is that firstly, the old idea perhaps of kind of progression towards humanity through time is not a linear process. There have been lots of side experiments, if you like. Animals that did very different things from what humans do diverged from us, our immediate lineage, and developed their own unique features and then became extinct. So, and you can see then it's become quite a bushy affair now. It's not a single lineage, it's quite a bush, and at certain points in this bush, there are a number of different species living today. We're unusual in being the only hominin living today, but in the past, there were often 3 or 4 or 5 species living, not necessarily alongside one another, but occupying the planet. So times have changed. The other thing, of course, is that as we move from modern humans here, Homo sapiens, back through time, these creatures get progressively more primitive. One of the characteristics of the fossil record is that as you wind back the clock, the creatures that came earlier in time tend to be more primitive than those that are living today. So that's the kind of story. I'm not going to go through this in great detail. What I'm going to do to you today is just present a couple of case studies of the kind of research I do based on aspects of this chart here and to kind of give you an insight into the kinds of job that I have, the kind of research that I do. The first case study I want to focus in on is Australopithecus afarensis. This is an early hominin, and it's highlighted here, the time period here. It's about 3 to 4 million years in age. This is the iconic specimen that's associated with this species, and it's been referred to as Lucy. It was discovered in the 1970s by Don Johansson, one of my colleagues at Arizona State University. And I'll give you a little bit of a summary of what this is about, and then what I'll do is I'll come on to my own research and how I intersect with Australopithecus afarensis. It's been something I've been working on for about 20 years or so now. So let's take a quick look at afarensis. I'm not going to go into great detail here, but it's an interesting creature. It's really one of the best known of this early hominin group, because it's known from about 3,000 specimens. It's a large number of specimens. They come from a number of sites, as you'll see in a moment, in Eastern Africa. You can see from the skulls here, the cranium here, that it's got a very small brain case, only slightly larger than a chimpanzee, so quite primitive. It's got this big, rugged, robust face. It does have small canines, so one of the early hallmarks of hominins is there present. That canine's actually pushed up a little from its original position. That would be better. So it's a relatively small canine. It's got big, rugged teeth for powerful chewing and thick jaws. But really the most amazing part of Australopithecus afarensis is that once it was discovered, it became very clear that the characteristics of the hind limb, the thigh and lower leg, and the hip region are that it's built for moving around on two legs. It's got relatively long arms still, and there are aspects of the hand, and it's known from several skeletons. We know from its hands and from its upper body, really, that it was quite adept at climbing in trees. It hadn't given up, probably, life in the trees. But what it was very good at was moving in a human style on the ground on two legs at up to 4 million years ago. So it's a very important and iconic specimen, Lucy, but it's also a really good point of reference for later stages of human evolution. It's still quite a primitive creature, but it's got some of the hallmarks that I've just mentioned of later humans. It's known from a number of different sites. It's known from Hadar and Dakika. Hadar is where the largest sample is from. Lucy is from Hadar. These are sites in Ethiopia. A newer site that's yielding very nice material is Woronso-Mille, also in Ethiopia. There's a few specimens at Kubifora in northern Kenya on the Turkana Basin. And then the site that I'm working on here is at Laetoli, the southernmost site. This is one of the oldest sites with afarensis, Australopithecus afarensis. Now, you may notice that these are all strung out in a line, and that's not a coincidence. One of the characteristics of this part of Africa is that the rift from the Red Sea continues all the way down here. It meets Tanzania and splays out because Tanzania has a massive block of granite sitting under it. And the Rift Valley, and what the Rift Valley is East Africa is slowly spreading out into the Indian Ocean. It's separating from the rest of Africa, leaving behind deep valleys, deep gullies, big lake basins, as well as volcanic tectonic activity. So what you've got here then is the last of that Rift Valley extends down all the way from Ethiopia all the way down to northern Tanzania, where Laetoli is, and then it peters out. It basically finishes. Now, the great thing about rift valleys are volcanoes produce lots of sediments, and sediments are the business I'm in, because what happens is it buries fossils and preserves fossils. So places that produce lots of sediments are great locations for paleontologists to work because it preserves extinct organisms. This is a bit more of a detailed map over here. And there you can see Laetoli. It's all these areas here. It's just south of Olduvai Gorge, which some of you may be familiar with, a very famous archaeological and paleontological site. It's younger than Laetoli, and it's where the Leakey family have worked for a number of decades from the 1950s onwards. The other thing that I'll highlight for you is, though, here's one of the rift lakes, Lake Ayazi, and Laetoli is uplifted. The lake is about 2,000 meters below where Laetoli is, and it's an incredible drop-off. It drops right into the lake. And off to the east are these volcanic highlands, the Ngorongoro volcanic highlands. Right there is the caldera, the collapsed volcanic center of the Ngorongoro crater. So it forms a big crater, and many of you know it from wildlife films and so on. It's a beautiful place to visit. So there are these volcanoes, and those are producing the sediments that have covered the bones at Laetoli. And we'll talk a little bit more about that in a moment. So that's the background. I've been working at Laetoli close to 20 years now, and we have been working on Australopithecus afarensis. Now, this is me here walking along, and you can see what the kind of terrain is like. This is what's called the Serengeti Plains. We're in the southern part of the Serengeti Plains. These are where the exposures are, where the fossils are collected. It's not a very, glamorous kind of site in some ways, because you often think, sweeping exposures where you're going to pick up fossils. Laetoli's not quite like that. It's mostly grass-covered and bush-covered, but there are these exposed areas where the fossils occur. Here are the volcanoes off to the east here. So we're looking east here, and this is Lemmergrut over here, one of the larger volcanoes. It's not active any longer, thank God. So what you've got is these, and there's my campsite, is over here near this hill. So I've been working there for some time, and we've been working on a number of things with Australopithecus afarensis. We have been working on finding new finds, but the other thing that we've been doing most importantly is trying to understand the context, what the life of Australopithecus afarensis was like. What was its diet like? What was the environment and ecology like? What did it do during that time? It lived in Laetoli for about 300,000 years or so. And that's really the important question, because it's easy enough to document the steps in a human evolutionary story and just say, here's more fossils to put on the map. But it's really important to understand why things happened and how they happened. Those are important questions. They are difficult questions to answer, but those are fundamentally important. So that's what we've been doing. We've been trying to understand the context of Australopithecus afarensis at Laetoli. Now, Laetoli is an interesting site. And one of the reasons it's an interesting site is that it does have good remains of Australopithecus afarensis. One of the unusual, one of the unusual features, though, is that there is no water there. Most of the sites in Eastern Africa are associated with rivers and lakes, and those form sediments that bury the fossils. At Laetoli, there is no evidence of water. It's all volcanic ash blown out of the volcano and burying any bones or carcasses that were lying on the surface at the time. So what we've got there is then an unusual situation, an unusual preservational situation at Laetoli, which is different from all other sites. We know it was drier and less wooded than other sites, and water would have been in short supply, probably for about 8 months of the year. Very arid for quite some of that time. So these are the volcanic ashes that have been deposited. You can see forming layers, different layer up here, that are burying the fossils, and we just move around here looking for fossils in amongst these exposures. So this is one of the reasons it's got unusual preservation. We find, for example, some unusual fossils that you don't find at other sites. Lots of insects, for example. Lots of ground-nesting bird nests, and these are perfectly preserved eggs. It's hard for me to even get eggs back from the supermarket in one piece, and these have been 3.5 million years sitting under volcanic ash, not crushed at all. It's unbelievable. So they're beautiful, different preservation, and we have some really important contextual clues then about the life of Australopithecus afarensis. So here's my campsite here. Since we're in the Serengeti, we're camped out. There's no running water, there's no electricity. It's a basic tented camp. When we leave, nothing is left behind, and when we arrive, there's just trees and grass. It's a fairly open area. And there's usually a team of about 15 to 25 people that are working, including students, graduate students, and scientists from various disciplines. This is me here collecting here with a student. And this is my colleague that David mentioned in the introduction, Amandus Quaker, who's at the National Museum of Tanzania. He's the co-director of the project at Laetoli. That's me there in my younger days. So we have made new discoveries, as I mentioned already, and those are really important for filling in not just new fossils for Afarensis, but also its life ways and its context, the environment it lived in. Now, as you can imagine, it's a wildlife area, and we're on foot most of the time. There are no roads, so basically you can drive some of the way, and then you have to get out of your car, and often we walk about 10 to 20 kilometres a day and spend most of the day out in the wild. As you can imagine, this is a glorious place. One of the things I like about it is I can really imagine what life was like 3.5 million years ago because I'm surrounded by the wildlife that lives in the area today. It's very well populated by wildebeest, zebra, giraffe. I just have to open my tent door in the morning and they're walking by the camp. But we do have these encounters, and it makes interesting graduate training, I have to say, because we have to, inform students. Excuse me, let me just take a sip of water. I've got the same problem that David has. I'm just getting over the flu. Let me keep that there. So, one of the things that we have to do is obviously teach our graduate students about what to do about fossils and finding them and how to map them, but we also have to tell them what to do if they encounter an elephant on foot, a buffalo on foot, a lion on foot. Fortunately, we haven't had too many encounters with elephants or buffalo, some, pretty much one a season perhaps. We have many more encounters on foot with lions. And I have to say, it's all well and good to see a lion in the zoo and you think, wow, that, I wouldn't want to meet one of those in the bush. And I have to say that it really gives you a primal fear when you encounter a lion, 25 feet away from you, and you're out there we have no guns or anything like that. We just have to manage and back away. Usually lions are not, in this area, are not very aggressive. And usually if you back away and they give you a warning, usually they give you a big roar and warn you that you're coming too close and you know slowly to back away. So it's a wonderful area to work because there's so much natural history around you that you can learn about what things might have been like 3.5 million years ago. Excuse me, sorry. So, moving on. So one of the things about Laetoli is and this is what we would call a stratigraphy. This is the sort of sequence of events. This is the oldest down here going up to the youngest. These are the various beds at Laetoli. I'm not going to go into great details. But in what are called the Laetoli beds, dated to 3.6 to 3.85, as I've mentioned, we've got Australopithecus afarensis. There are other hominins higher up the sequence. At 2.7 is a thing called Paranthropus ethiopicus, a very interesting and very specialised form of hominins that seems to have gone nowhere in terms of later species. It gave rise to a small radiation during this time period, but then becomes an extinct side branch of humans. And then at about 200,000 years ago, modern humans appear in the fossil record at Laetoli. So we've got a bit more of an interesting record at Laetoli. It's not, Olduvai Gorge, but it's still one of the most famous sites. Now, but I do want to draw your attention to this area here, the lower unit, because I'm going to talk about that in a few moments. The lower unit is about 4 to 5 million years in age, a very important time period in human evolution. We have no hominins from there, but we are actively looking. We will be returning in 2019 where we will focus on the lower beds, and I'll talk more about that in a moment because that will be my second case study. Laetoli is also very important because footprints were discovered there, fossilized footprints. And this is a remarkable discovery. It's one of the few sites in Eastern Africa that have fossilized footprints. This is Mary Leakey over here, working on some footprints, and these were discovered in the mid-1970s. Mary Leakey had been working at Laetoli for about a year or so when one of her workers accidentally discovered footprints in the volcanic ash. Now, this is volcanic ash that's solidified. One of the things about the volcanoes that are producing the ash is it's called a carbonatite volcano, which produces a thing rich in calcium carbonate, which is basically the chemical structure of concrete. So basically, when it falls and gets moistened, it turns to a concrete-like structure. So what happened in this situation was a number of animals walked over the ash while it was unconsolidated. It then got dampened slightly by either a heavy dew or we suspect a rainfall, a slight rainfall. And then after they left their footprints, they solidified and are preserved to this day. And you can see here a rich array. An elephant walked this way, a hyena did something strange, it walked this way and then back again, and a number of other animals, birds and mammals walked across this little patch. Mary Leakey then realised that there was potential here to really find footprints for the humans, or the hominins, Australopithecus afarensis. And that's what she discovered in the mid-1970s at a site called Laetoli Site G. This is the trail of footprints. Today it's been buried to preserve it. As it happened, even in the 20 years I've worked there, I have never seen the original prints, only the research that was done on it. And you can see that there's a trail of prints going here, sort of a larger set of prints, and then a clearer set of prints going this way. And this is a map of that, and a bit more of a close-up detail, a bit more of a fine, detailed look at it. And what you can see from this, though, is that a trail of prints, and it's clearly a bipedal animal, an animal walking on two legs like you and I. Left, right, left, right, left, right. Clearly not an animal walking on all four legs. Afarensis. Now, the interesting thing about afarensis is we had surmised from the paleontological record, from the skeletal evidence, that it was a biped. But it was always an inference. What we've got here, remarkably, is fossilized behavior. This is an individual that walked across the ashes, left their footprints, and told us that when this animal moved on the ground, it definitely walked on two legs. Now, the interesting thing about this trail is this is a smaller individual. Then a larger individual walked alongside it. They couldn't have walked side by side because those two tracks are too close together. But they were walking in quick succession. And another individual, a third individual, walked and stepped in exactly the same tracks as individual number two, which is quite unusual. A very human characteristic. You and I do this. You know, if we're walking through deep mud, we tend to follow in somebody else's footstep in case we go neck deep in, a big hole of mud. If they've got through safely, we can follow in their footsteps. So Australopithecus afarensis did something similar, walking in this trail. Now, we don't know when these were made. They could have been made hours apart. They could have been a small party moving together. It would have been in a very short period of time. This is not weeks apart. This may have been hours apart or at most days apart, but probably hours apart or instantaneous at the same time. So this is clearly very important evidence. And I'll come on and explain to you a little bit more about footprints in a minute. The nice thing about this is in 2016, more recent research has been done and have found some new footprints at Laetoli, not very far from the original site, about 150 metres away. And it's amazing that no one decided that, hey, look, we've got footprints at one place, maybe we should try and excavate a little further away to see if there are other footprints. And that's what somebody did. Somebody was just doing an archaeological survey, dug down, found more prints and said, whoa, these are really important. And what you've got is another set of prints, two individuals actually, this is one here and another one here, walking in exactly the same direction as the original prints. So it's interesting, they're all walking towards the north. We don't know why they were walking, but you've got to remember, this was quite a heavy fall of ash. Conditions wouldn't have been very conducive to living in the area during that fall of ash. It was about 30 centimetres deep. It would have buried much of the local vegetation. Trees would have had branches and leaves stripped from it. So it would have been quite a devastating thing. And the fact is that heading north is the quickest way out of the volcanic zone. It's only probably 5 or 10 kilometres to walk to move out of it. So the other interesting thing about these new prints is that they indicate a larger individual. Now, we do know that Australopithecus afarensis had different sizes. It came Lucy size, about 3 feet tall. Lucy would have only been a really tiny creature, very slightly built. But there were also more rugged individuals. There's an individual from Ethiopia, a skeleton, partial skeleton that's been found recently, and that was a much more rugged and quite a tall individual, about 1.5 meters, about 4.5 feet tall, so quite a bit taller than, and presumably these are males and females, quite a bit bigger. And the prints tell us there are big individuals, and just like this set of prints here, a big individual was 2 big individuals and a smaller individual, presumably male and female. But let me go back to talk about feet and footprints a little bit, because this is an important point I want to dwell on. We look at human feet and think, well, that's very commonplace. We look at our feet and think, well, that's not so unusual. But as it happens, we have very weird feet. They're not commonplace at all. This is, and I've got this young chimpanzee obligingly showing his foot for us, but you can see this is what a respectable hominoid foot should look like. It's got a very broad foot, it's quite flat, it's got long curved fingers, and the big toe is diverging. It's opposable and can be moved like you and I's thumb to grasp branches. It's a grasping appendage. Humans have given up for that. It's a compromise because in our evolution, to walk effectively bipedally, we couldn't have a foot like that. But what we had to give up was effective climbing in trees. All of us know people can still climb trees relatively effectively, and some people are very good at it. I'm hopeless at it. I fell out of trees as a kid all the time, and it wasn't just because of my feet. I'm just a bit of a klutz. But the fact is that this is what hominoids had primitively. Humans have modified those feet, and how they've done it is they've developed a big heel process, a big, powerful heel process, and I'll explain why that is in a moment. Then we've got an arch in the middle of it, in the sort of central part of the foot here, and it sort of arches longitudinally and transversely this way. Then we have a large kind of ball of the foot, short lateral toes. The little toes are short by comparison to these guys over here. And we've got a really big and powerful big toe that's pressed against the other toes. Now, I know some of you can probably do party tricks with your toes and big toes and grasp things, but that is a little freakish in my mind, and you shouldn't really be able to grasp things with it. To be a really good human, you have to have your toe closely pressed. Now, one of the things is, you've probably all grown up wearing shoes, and that has affected how closely pressed our toes are. If you are what we would call unshod growing up, not wearing shoes, there is usually a bit of a gap between the big toe and the other toes. It's because of footwear constraining our development early on. So our feet are a little bit more constrained than typically, but nevertheless, these are feet that are very different from a chimpanzee's. Okay, so if we go back to the Laetoli footprints, here's a human footprint in sand, and you can see some of those characteristics. But before I get to that, let me explain a little bit about bipedalism in humans. And what we're going to do is focus in on one leg here. Hopefully you can see that and nothing's obscuring it. And what we do is as we walk, we make contact first with the contact foot, what we call heel strike. We strike it hard with that very robust heel bone. Then we roll around the outside of our foot, across to the ball of the foot, and then we launch ourselves in propulsive fashion off using our toe, our big toe, and that's called toe off. So the two essence really are heel strike and toe off, important parts of our locomotion. The footprint clearly articulates that. Here you've got a deep heel strike in this human on sand. This is a modern human on a beach. You've got a heel strike. There's an arch here that comes around here where it rolls around the outside, cuts across to the ball of the foot, which is just behind the big toe, and then you've got a deep impression for the big toe as it toes off. So it has all the characteristics. You can tell a lot about how the foot is moving from the footprints. And the Laetoli print that you see here has all of those characteristics. It's got a deep heel strike, an arch, and a big toe that's closely oppressed. It's a bit shorter than the other toes, actually, but it is closely oppressed to the other toes and still a well-developed big toe. So we're talking about essentially a human-style foot in Afarensis, in Australopithecus afarensis, at about 3.5 million years ago. So quite remarkable. It's quite a remarkable piece of evidence at Laetoli. Moving on to the next case study. Let me just check how I'm doing for time here. And I'll probably sort of quickly go through this because I don't want to run long here. But the next part is, and these are quicker case studies, is the earliest hominins. These are the hominins at the very base of our evolutionary tree, dating from about 4.5 million years ago, 4.4 million years ago, back to almost 7 million years ago. There are a number of different species, and I've been involved in this, and I've kind of intimated my involvement already in this presentation. They are known from a number of different sites in Chad and Ethiopia, moving down to central Kenya. And they belong to 4 different species that range in age from about 4.4 back to 7 million. They are older in time than all of the Australopithecus that we've just mentioned. There's Australopithecus afarensis. There's a slightly older species of Australopithecus. And one of the things I'm going to emphasize is that there's a big departure from these very primitive creatures to getting to Australopithecus. And I'll come back to that point. Let me quickly introduce these early forms. This is Sahelanthropus, the oldest of the early ancestors, the earliest ancestors. And this is very close, at 6 to 7 million years, to the divergence point with chimpanzees. So we're really at the base of the human lineage here at 6 to 7 million years in age. It's from a site in Chad called Torres Manala, and is known primarily from this skull. And the skull is very ape-like in many ways, very gorilla-like in many ways, but it does have a couple of features that make it human-like. It's got small canines, and it also has the base of the cranium. When you look at it, it implies that it was a creature that may have walked upright. So two important characteristics of humans. But it's been quite a contentious creature in some ways. The next creature is Aurorin tuganensis. This is slightly younger, at about 5.6 to 6.2 million years ago. It's known from central Kenya. And most of the focus has been on this bone here. This is a thigh bone or femur, which is very indicative of bipedalism. And the characteristics of this suggest that it may have belonged to a bipedal creature. So there are incipient developments of bipedalism in all of these forms. The rest of the specimens that you see here are rather ape-like. So we know it's a very primitive ape-like creature, but may have been an early biped. Not so well known is Ardipithecus cadabra. It's slightly younger still at 5.2 to 5.8. This is known from Ethiopia. It's known from this scrappy material, but does seem to have relatively ape-like teeth, but maybe some indications, again, of bipedalism. And then finally, the best known form is this relatively younger form at 4.4 million, and it was published quite extensively in the pages of Science. Some of you may have seen it, published by Tim White and his colleagues from the University of California at Berkeley. And this is Ardipithecus ramidus. It's really provided us the best evidence of what some of these very early hominins looked like. It's known from sites in Ethiopia and is known from a partial skeleton, which really gives us some important clues to what these early hominins may have looked like. And this is what we see here. It's a rather crushed skeleton, but the reconstructions and the sort of 3D reconstruction of it give us some real clues. It's got a very small ape-like brain. It does have reduced canines, so a very human characteristic, and there's enough canines to know that they were all small. The interesting thing is also it's got these long arms and long hands with a short thumb, not very human-like at all. But where it becomes human-like seems to be in the lower limb. The hip region, as it's reconstructed here, and the fairly specialized limb structure tells us that it was a biped. Now, it's an interesting creature because not only is it bipedal, it also has a big toe that we saw that was characteristic of chimpanzees and other apes. It's opposable. It was actually able to climb well in trees. So you can imagine then you've got an animal that's quite adept at moving on the ground, but also quite adept in the trees. And we hadn't perhaps anticipated that you could be a compromise animal and do both very easily. So it's an interesting creature. All right, where do I come in here then? Because one of the important issues here is that Ardipithecus ramidus is not very much younger than the oldest Australopithecus. It's only about 200,000 years. Now, it seems like a long time, but it's a blink of an eyelid geologically for us. And the problem here is that all of these creatures are very, very primitive and have just incipient levels of bipedalism, whereas Australopithecus is quite an advanced creature with well-developed bipedalism. So that either requires a rapid evolutionary change to get to the earliest Australopithecus, or more likely that we would find pre-Australopithecus, precursors of Australopithecus, further back in time than this species, which is dated to about 4.2 million years. So we are going to perhaps find something more Australopithecus-like in the earlier record than these very primitive creatures that we've got already. That's where this part of my work at Laetoli comes in. These 4 to 5 million year old beds sediments in Laetoli are just the right age to begin to fill in that. We know Australopithecus afarensis appears at about 3.8 million. What preceded it? And in the next couple of years, I'm going to focus in on these beds. They are fossiliferous, they have yielded fossils, and we'll go back there and try and fill in and answer that question about how these are related to Australopithecus, if they are at all. The very last snapshot I'll give you, and then I'll wrap up, it's just a few minutes here, is that I've been also working on later stages of human evolution. So I've talked about the early stages, the kind of middle stage, and now I'm going to talk about the early stages. And I'm going to talk about modern humans and early modern humans and the species that preceded them, Homo erectus, that originated in Africa about 1.9 million years ago from a form called Homo ergaster. And Homo erectus and Homo ergaster are sometimes grouped together, but Homo erectus is essentially an Asian form if it's a different species. And that left Africa about 1.8 million years ago. So one of the things that you've probably noticed is that human ancestry is very much an African story. Our evolutionary history was entirely African for the first 5 million years of our evolutionary history, exclusively African. And then after that, early humans in the form of Homo erectus get out of Africa for the very first time. Hominins appear in the rest of the old world, and dramatically. And that's the point of my research. So we're going to look a little bit at Homo erectus, a little bit at Homo sapiens, and I'm going to focus in on the work I've been doing in southern China. And I've been working in a place called Guangxi. It's technically called Guangxi Zhuang Autonomous Region, and that's because there's an ethnic minority group there called the Zhuang, who speak a different language from Han Chinese. And it's a big group, several million, I think, and they occupy this region in southern China. It's a beautiful area. I'll come back to that in a second. I've been working mostly with Jin Changshu and Zhang Yingqi, who are my collaborators there in China. They are at the Institute of Vertebrate Paleontology and Paleoanthropology in Beijing, one of the premier institutions working on human evolution anywhere in the world, but certainly a very important one in China. It's a beautiful area. Today, these mountains, which are limestone mountains, being cut down by erosion. One of the things is limestone was formed at the bottom of oceans hundreds of millions of years ago. And since it occurred and was thrust out of the oceans, it's been weathering down. It's soluble, limestone, so it tends to then create caverns and caves in the limestone, and you can see that they're cutting down sharply to the valley floor below. So these are big mountains, several hundred meters tall, and inside them are caverns that are full of bones. The ones at the top were formed earliest as it cut down, and the ones at the bottom are youngest. So there's actually a sort of a chronology to it. You can see that much of the area is surrounded by farmlands today. But in the past, when Homo erectus and Homo sapiens first arrived, it was shrouded in forest. It was a dense subtropical forest. It's a warm part of China. The only non-human primate that occupies it today is the white-headed langur, this creature here with its lovely tangerine infant that you see there. They're gorgeous animals. They've got spectacularly long tails, much longer than their bodies. They are the only ones that have survived on these little outcrops, isolated outcrops in China. But we know in the past, about 2 million years ago, when this story begins in Guangxi province, 2 million years ago and onwards, there were many, many more primates living alongside Homo erectus. There were 5 different species of ape, including the one I'm going to talk about, but apes were living there, and there were about 6 different species of monkey. They were all living there. The sole survivor, other than humans, is the white-headed langur. But it meant that when Homo erectus first arrived in southern China, it encountered all these other kinds of apes and monkeys. And as you might imagine, Homo erectus is a bit different from the earlier forms we've been talking about. It was actually quite a voracious predator and probably quite a proficient hunter. So, China has a very good and growing record of human origins. We know that some of the earliest evidences from southern China at 1.7 million years ago is Homo erectus. There's an intermediate form called Homo daliensis, which is kind of like a Neanderthal version from China. And then Homo erectus appears Homo erectus appears at 1.7 million and continues up in time to the famous site of Zhoukoudian near Beijing. And then about 100,000 years ago, from Daoxian and Jirendong, is human material, modern human material. It's a very early. China now has some of the earliest evidence outside of Africa of modern humans. So what I really want to do is, in that time period I'm interested in, looking at those caves in southern China, is the interaction of Homo erectus and modern humans that arrived there. What impact did they have on that primate fauna, that hominoid fauna that we saw? Homo erectus is a different creature from Australopithecus afarensis. It's tall, with long legs, a larger brain by comparison, shorter faced, and behaviourally and culturally quite a sophisticated creature. It's those long legs that allowed it to get out of Africa for the first time. The ranging behaviour it has, the energetics of locomotion are much improved in Homo erectus, which gave it the capability to migrate over longer distances than did afarensis. And that was the key to the first out of Africa. But I'm interested in this creature. It's not a hominin, it's an ape, and it seems to be a cousin of the great ape, and it's a thing called Gigantopithecus, and it's aptly named. It's huge. It would have been about 8 to 9 feet tall. It would have weighed 200 to 300 kilograms, so a massive ape. The largest ape that ever lived was there in southern China at that time period. It lived from about 2 million years ago, that's when the record begins, up to about 320,000 years ago. And then it suddenly disappeared. And what I'm interested in trying to uncover is, what was the cause of that loss? This great, massive creature that I would love to see in real life. And you can see here, this is a human jaw for comparison against Gigantopithecus jaws. You can see how much bigger than a human jaw it is. And it's got these massive teeth. It clearly was a specialized ape. But what I'm interested in is, how did it interact with the arrival of humans? And I suspect that Homo erectus had a hand in its downfall, just as Homo erectus and Homo sapiens have done with other species of apes and other mammals. So I'm trying to uncover what went on in southern China at that time period. Here's a graphic for you to close on. Gigantopithecus here, very interesting little guy romping around here. Some of the other animals, here's the karst, the limestone mountains, lots of bamboo and dense forest. And here are sneaky Homo erectus over here, well armed with their culture, eyeing up their next meal of Gigantopithecus. And I suspect that they would have had quite an important impact on Gigantopithecus. So that's the interesting thing. So there are different ways that you can look at the human fossil record, and different ways that you can kind of begin to weave together the facts surrounding human origins. So I'll close there. Thank you very much for your attention.